Derivative test, its purpose, and I'm going to abbreviate here, it's actually going to change to this because I like this. The first derivative test does this. It finds, see, this is why I did this, because I can erase my mistakes. Finds whether the critical points are a relative max or min. Remember, just because you have a critical point doesn't necessarily mean it's a relative max or min, but if there is a relative max or min, it has to come from a critical point. So, you know, there's an infinite number of points on a curve, right? We're able to say, hey, it's possibly these 2 or 3 points, okay? So what I have here, I know some facts about this. I know that f is a parabola opening up. So I know this vertex right here is a minimum, correct? And what I can see over here is, first of all, that on this side, f of x is going down. I mean, it's easy to see. I also know, since f of x is going down, that its derivative is less than 0. On this side of the vertex, f of x is going up. And its derivative is positive. And exactly at this spot right here where x equals 2, there is a horizontal tangent line. What does that mean? It means that that derivative is equal to 0. That x equals 2 is a critical point. So, this is what I can see from the graph. This right here, I'm going to draw a little wave. This is the calculus. And then it's going to start out just like what we did before. We're going to find that derivative, that first derivative, which in this case is 2x minus 4. We're going to make it equal to 0. And we're going to find our critical point, that it is x equals 2. Okay? Nothing that you just didn't do on the pop quiz, right? So now this is going to look a lot of the same. I'm going to create intervals. And I'm going to go from negative infinity to 2 and 2 to infinity. I already know that f prime of 2 is equal to 0. I said that right here, didn't I? I already know it's a critical number because it makes the derivative 0. So then what I have right here is a test value. Audrey gave us test values. I think you said negative 3, 3, and 1, I think, correct? Well, I'm going to choose 3, I'm not going to choose 3, I'm going to choose 1 and 3. I don't know why I chose. So I want to pick those numbers that are in those intervals. And then I'm going to look at the sign of the first derivative. And if I look at the sign of the first derivative and I take that 1 and I put it into here, I'm going to have 2 minus 4. I know that's a negative number. I don't care what the value is. I just know that that's a negative number. So in that interval, my derivative is going to be negative all along there. the slopes of those tangent lines will be negative. When I put 3 into here, I'm going to have 6 minus 4. I don't care what the value is. I know my answer is positive, all within that interval. And if you look on that side, you would have tangent lines that are going up from left to right, correct? So what's happening? Well, what's happening to F? F is going down here, and then it's hitting 0 at 2, and it's turning going up. So I can say this.
I cannot write all that because they write too big anyways, but I think I get the gist.
Okay. I'm going to write it over here in the margin too, because I'm having issues. I'm going to say, I'm going to put 2 into F, and when I put 2 into F,
F prime or F?
into F, I'm going to have 4 minus 8. Well, I can see right here the point's -6, right? So if I have 4 minus 8, I'll get -4, minus 2 is a -6. So I can say 2 comma -6 is a minimum since F prime changes from negative to positive.
So if it changes from negative to positive, it's a minimum. If it changes from positive to negative, it's a maximum.
Correct. In fact, that's going to bring us to our next line right here. It says, these are your justification statements. Assume C and D are critical numbers of the function f. There is a minimum value at x equals c because the derivative f prime changes from negative to positive. Matthew, that's just what you were saying. And there is a maximum value at x equals d because f prime changes from positive to negative. In other words, it looks like this: positive to negative, negative to positive. Are we doing okay? So it's going from decreasing to increasing, from increasing to decreasing. All right, it says here, use the first derivative test to find x values of any relative extrema of f of x equals this. All right, so our first step, well, the first thing I'm going to do, anytime this, in my head, I look and say, are there any restrictions? Are there any numbers I can't put in there?
No, because it's, at most it's a cubed root. It's a cubed root.
Right. So you can put anything you want in there, correct? Would everybody agree with you?
Yeah,
So I'm just going to write
it's
all reals right here. Now, the first thing I'm going to have to do, what Ben said, was find the derivative, which is finding the critical numbers, right? So I'm going to do the derivative. And I'm going to say that f prime of x is equal to 2/3 x squared minus 4 to what power, Callan?
-1/3.
Perfect. And then the chain rule says, that's a negative, by the way, needs to say, hey, I got to come in here and take the derivative of this x squared minus 4. And what is that?
2x.
2x. Perfect. Everybody okay with that? Now you got to remember that when you have a rational expression, something that's in fractional form, we said every number is allowed. So we are going to have to take a look not only in the numerator, but in the denominator. Because sharp points can be relative minimums and relative maximums. Think of the absolute value. That's the letter V, right? It has an absolute minimum, doesn't it? It's a sharp point. That sharp point just means it's not differentiable there. But it could be the lowest point on the graph or the highest point on the graph. Is that clear to everybody? All right. So I'm going to write this in fractional form. And do you see, does everybody see where I get 4x on top? I got 2 here, I got 2 here, I have x. The 3 is obviously in the denominator because that's where it is. Because that has a negative exponent, I can write it like this. Oops, I made a mistake right away. So, first thing I'm going to say is I'm going to let 4x equal 0, x equals 0 is one critical point. Can this be 0? In other words, this x squared minus 4 is what would make it 0, correct? What numbers can I put in for x that would make that 0?
2 and negative 2.
2 and a negative 2, right? So I'm going to say x equals plus or minus 2. So these are my critical points. I have 3 of them. That means I'm going to have 4 intervals. It's going to go from negative infinity to negative 2, from negative 2 to 0, from 0 to 2, and from 2 to infinity. Negative 2 is a critical number that gives me 0 in the denominator. 0 is a critical point that gives me 0 in the numerator. Positive 2 gives me 0 in the denominator. So, Jonah, tell me what number you would like here.
Negative 3.
Negative 3. I should make, I just thought this, that felt like a game show host. I should be a game show host called Name Your Calculus. Just a second. All right, what about here, Jonah?
Negative 1.
What about here?
1.
What about here?
3.
Okay, so this row represents the what?
The test values.
That go into what?
The
It's called the first derivative test.
they go on derivative.
The derivative, okay? And we're just gonna put plus or minus signs here, correct?
Yeah.
So and my derivative's over here, correct? Now, we can do a little bit of thinking here. We can make life really easy. If I put 3 and a negative 3 in here, won't it be positive? But if I put a negative 3 here on, right, won't you get 9 minus 4? And that's a positive number. Whatever else you do to it, it's going to stay positive. Okay, so I could do these two at the same time because I'm squaring them. Everybody okay with that? So if I put 3 in here, if I put a negative 3 in here, what's it going to be, Jonah?
Negative.
Negative, because you'll have a negative 12 on top. And if I put a positive 3 in there, it's going to be what?
Positive.
Because you'll have a positive divided by a positive, correct? Now, you put a negative 1 in here. When I put a negative 1, or if I put a 1 in here, this quantity is going to be what?
Negative.
Negative. So if I put a negative 1 up here, I have a negative over a negative, correct?
Yeah.
So it's going to be,
Positive.
and if I put a 1 in here, it's going to be a positive over a,
Negative.
and be
Negative.
negative. I'm going to give you a hint. They don't always switch. So just don't assume, hey, this is negative, that one's got to be positive, that one's going to be negative. You got to check.
Well, if it goes from a negative to a negative,
Then it's not a relative anything. Okay, and I'll give you an example of that in a bit. That's a great question. Okay, I'll give you an example like that in a bit. So now, if you take a look, what's F doing? Well, this tells me a whole bunch of things. F is decreasing here, it's increasing here, it's decreasing here, it's increasing here. So, do I have, so let's see, where am I on here? So it looks like this, looks like this, looks like this.
In between those, I just put max, instead of putting those curves, I put max or min.
Okay, so Ariana, are there any relative minimums?
Yeah.
Where? Relative min at x equals a -2, correct? Because remember, x equals a -2 is right in here, and that gives you a slope of 0. So right here is x equals a -2. Right here is x equals 2. Okay? So you say x equals a -2 and x equals 2 since f prime changes from what? Negative to positive. Excellent.
So I put -2 and 2 are min, relative min, since f changes from negative to positive.
Yeah. I should have said relative min right here. That's my fault. Relative max, any? Ariana?
Yes, there's one.
At x equals 0?
Yeah.
Since?
F prime changes from positive to negative.
Perfect.
You can only have enough room for the relative min.
Okay. Now, your question before. You ready? Backside. See this? It should be empty. That's a 3. X cubed. Same steps. Derivative equals 9x squared. Would everybody agree? 9x squared equals 0. Correct? The only thing that gives you 0 is when x is 0. This is my critical point. Guaranteed. Why? Because the derivative is 0. Everybody with me on that? Now, negative infinity is 0. 0 to infinity. Test value. Matthew, give me a number between negative infinity and 0.
-3.
How about -1?
Yeah, and then we can do +1.
Okay. So now, into f prime, which is 9x squared. I put -1 in there, it's what?
You get a -3.
No, you're putting it into here.
Oh,
You put it into the derivative.
it's a positive.
It's a positive. Okay, that's a good point. With common mistakes is people put it back into the function. You're putting it into the derivative. The derivative is telling you what the function is doing. Like when my parents were gone and they knew something was up, you know what they did? They didn't grill me, they grilled the youngest. Because they would know the youngest would squeal. Okay? We don't look at it in the function, we don't look in the older one, we go to the younger one, which is the derivative.
So
It'll squeal.
So the function exists only to create the derivative in these situations.
Correct. Okay, so now, Matthew, when I put 1 in here, what do I get?
9. Oh, positive.
A positive. It didn't change, did it? It's not a relative min or max. It's something else. We'll be talking about what that something else, but it doesn't change. And if you graph this, you would see it probably goes something like this. That's bad drawing, but something like that. Okay, it doesn't turn around, it doesn't change direction. Something else is happening right there. And we're gonna talk about that. But don't just assume because you see the positive that the next value is gonna give you a negative. You doing okay? All right, back here. Remember, if C doesn't exist, if it's not part of the domain, then x equals C cannot be a critical point. Like when I look at this, right away I say, hey, 4 won't be a choice because 4 is not in domain. That little boy in kindergarten, if he shows up to that party, the mom will be shocked because he didn't get an invitation. So what's he doing here? Causes a problem. You let a little 5-year-old in, or you send him home? Grace, you know what you do? You send him home. Alrighty, so I'm going to compute the derivative.
Quotient rule?
Quotient rule?
Yeah. I'm pretty sure that's what it's
You think it's the quotient rule? Owen, do you think it's the quotient rule?
Yeah.
Okay, what's on the bottom, Owen? Want me to give you a hint?
1 second. It'll be 2x.
It's 4 minus x on the bottom, squared.
All that.
You start on top,
Yeah.
okay? Then up here will be 2x.
2x times 4 minus x,
Yep.
and then minus x squared minus x.
What's the
Times
derivative of
minus
this?
Minus x.
It's a negative 1x you're taking the derivative of, right?
Negative 1.
Negative 1. Very good. So now I'm going to have 8x, is that right, Owen? Minus 2x squared?
Yeah.
Plus x squared over 4 minus x squared. Do I even look down here? No, because it's going to give me 4 and I can't choose it anyway, right? So up here I'm going to have 8x minus x squared equals 0. Owen, am I doing that correct?
Yeah. I think.
Well, okay, a minus 2x squared plus x squared, is that a minus x squared?
Yeah.
Okay. So I'm going to factor, and I'm going to factor on x, and I get 8 minus x, and I get x equals 0, and x equals 8. Would you agree with that? Okay. Everybody cool so far? Now, I don't know what that graph looks like, Grace, but I know this for sure. 1, 2, 3, 4. There's one of these there. You know what that is? An asymptote, correct? And a graph never crosses a vertical asymptote. If you are you into sci-fi? So if I say force field, that doesn't mean anything to you. Okay.
I know sci-fi.
Okay. Do you know what a force field is?
Yes, it is something you can pass through in different types of media, but usually it's supposed to be a form of defense.
Well, in math, you don't cross it. Not a vertical one.
Just like you don't cross John Wick.
But it's a barrier, right? The graph on this side could look different than the graph on this side. Does everybody understand that? So when I do my first derivative test, I have to include it, but it's not going to be a relative min or max. So when I set this up, I'm going to have negative infinity to 0. I'm going to have 0 to 4. Because it's a separator. And I'm going to have 4 to 8 and 8 to infinity. My only answers are going to be 0 and 8, not 4. Okay? But I have to include 4 because it separates the graph. Is that kind of making sense to everybody? All right. So test value, Tyler, I haven't called on you for a long time. Here, 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 here. Okay, and we're putting it, we only really have to look, because down here it's always going to be positive, right? Whatever we do. Would everybody agree? Whenever you square something, it's positive. So you really only have to look here, correct? Right, that's your numerator. So, the derivative. If I put a negative 1 into here, what do I get? Negative, right? I get negative 8 minus 1. If I put a 1 in there, what do I get? Positive. If I put a 5 into there, what do I get? And if I put a 9 in there, what do I get? Yeah, I think it's 72 minus 81. Okay? So, over here, I'm going to say that, do I have, right here at x equals 0, here's x equals 0 right here. Here is x equals 8, correct? So Tyler, a relative what at x equals 0? Since
F prime changes from negative to positive.
and what about, there's a relative max at what?
X equals 8.
Since
F prime changes from positive to negative.
Alrighty. So, there's a little caution down here. What is a maximum value? The maximum value is the y value. In other words, it's f of c. So in this case, f of 8 would be my maximum value.
And where it is would be,
And I would have put that into here and got 64 over a negative 4.
okay, I think I understand this, so should I rewrite what you're writing down?
It's up to you,
I guess I won't then.
okay? And this is where x equals c. Where is the maximum? This is an x value. This would be at x equals 8. So can I show you what this graph looks like, or am I going too fast? Okay, so if I take a look at this graph, and I have x squared divided by parentheses 4 minus x. No, I did something wrong. Oh, I know what it is. It's my window. No, it's still my window. Okay, so you see how this is a relative minimum right here? Here it's a relative maximum. I think I can show that a little bit more. Right here. Now this point's lower than this point, but remember, it's within a little tiny neighborhood, correct? It's not the maximum overall, it's not the absolute max, but it's the maximum in that neighborhood.